हेलो एवरीवन, आज हम ज्योमेट्री इस कॉन्सेप्ट को जानेंगे अच्छी तरह से। बहुत ही इजी है ज्योमेट्री। चलिए स्टार्ट करते हैं। इसे क्या कहते हैं आपको पता है? इसे कहते हैं डॉट। इसको डॉट कहते हैं, मगर ज्योमेट्री में इस डॉट को हम कहते हैं पॉइंट। Point. So a dot is represented as a point. So we represent this point as capital letters like A, B, C, D and so on. So we represent point with capital letters A, B, C, D and so on. Geometry में आपको कौन से नए वर्ड सुनने को मिल जाएंगे? वो है point, जो कि अभी मैंने डिस्कस किया है, लाइन, लाइन सेगमेंट, line segment, ray, plane shapes। इसके बारे में मैंने एक वीडियो भी बनाया है, इसकी लिंक भी मैं डिस्क्रिप्शन बॉक्स में दे दूंगी, आप चाहे तो उसको भी चेकआउट कर लो। दूसरा वर्ड है जो कि नया आपको देखने को मिल जाएगा इस कॉन्सेप्ट में, वो है सॉलिड्स और सिमेट्री। सो ये सारे कॉन्सेप्ट्स आप ज्योमेट्री चैप्टर में देखने को मिल जाएगा। मैं अभी बता रही हूँ कि आपको ज्योमेट्री बेसिक्स। तो पहला है पॉइंट। ज्योमेट्री में ये डॉट इज रिप्रेजेंटेड एज ए पॉइंट एंड वी रिप्रेजेंट इट एज A, B, C, D, capital letters, so and so on. So this point shows an exact location. So it has no length, it has no breadth or depth. A point has no length, no breadth or depth. ऐसा रिप्रेजेंट कर सकते हैं A point, B point, C point, D point. So here A, B, C and D are points. दूसरा है लाइन, लाइन सेगमेंट। इन दोनों के बारे में मैं डिफरेंसेस भी बता दूंगी, क्या इसमें डिफरेंस है, व्हाट इज द डिफरेंस बिटवीन द लाइन सेगमेंट एंड लाइन। चलिए जानते हैं। तो लाइन सेगमेंट, सो फॉर एग्जाम्पल मैं यहाँ पे एक A to B एक मैंने लाइन बनाऊंगी फ्रॉम A to B। ये द पाथ फ्रॉम A to B, इट विल बी इन दिस वे, वी कैन गो फ्रॉम इन दिस वे, वी कैन गो इन दिस वे ऑल्सो, राइट? Here what is the shortest path? A to B, the straight line is the shortest path. Yes or right? Yes, the shortest path is a straight line, right? So we can draw a line segment. देखो मेरे पास ruler है, right? So a point A to point B. So we can draw a line segment from point A to point B, which is shown here with a ruler. By using a ruler, we can draw a line. Put your ruler in such a way that it's one of its edges touches the both points. Now, see, I put here from A to and B. I'm sorry, I'll show you again here from point A to point B. It's like so, A to B. See? Now you move the pencil from A to B along the edge of the ruler. Okay, from A to B. So the shortest path from A to B, it is a line segment. Here the shortest path is from A to B is the straight line. This is the straight line. So it is the shortest path. The shortest path from A to B is a line segment. So a line segment has two endpoints, that is A and B. So this is an endpoint and this is an endpoint. Okay, I'll show you a few more examples. I'll draw some figures here. So this is one figure, A, B, C and D. So this is first figure, right? And this is the second figure, like okay, right, like this, A, B, C, D, and this is one type of figure. Just put like this. Okay, so whenever two line segments meet, they meet at a point. You can see these following figures. So in the first figure, the line segment C to D, CD and AB are meeting at a point A. We are meeting in the common point A. In the second figure, line segments AB, CD are meeting at the point P. In the third figure, line segments AB and BC, they are meeting at a point B. Now coming to the next concept, that is line. So the difference between the line segment and line, what is the difference? I'll just show you. So a line is different from a line segment. I just draw a small simple example. I'll just show you. This is a point A and point B. So in line segment you have endpoints, but in line you don't have endpoints. So a line goes on forever in both directions. Okay, the picture here which I drawn by putting arrowheads at both ends. So these arrowheads at the ends tell us that it goes on and on in both the directions. It goes on and on in both the directions. So a line segment is a part of a line. It is a part of a line. So the other concept is ray. We just see. Ray. If I can go for so this is a sun. The rays of the sun. This is a sun, right? So think of these rays of the sun. Do they have any starting point? Yes, exactly. They have the starting point. So this is the starting point, and then goes on in one direction, right? Like this. If I can show in a line, so it will be like this. So it goes on in directions. So it has an end point, the sun ray. So it has an end point. For this line, it has the sun is the end point. For this line also, the end point is the same. So it have the starting point and they go on and on in one direction. So what is a ray means? A straight arrow that has no fixed length. It does not have any fixed length. Straight arrow that has no fixed length but goes on and on away from its initial point without coming to an end is called ray. Okay, a ray has one starting point, which is initial point, and this point is called its vertex. In plural, you can also say that vertices. The another word for this vertex is corner. Regarding this, you get to know better in the plane shapes concept. Okay, so this initial point is vertex. To name a ray, first name its end point. To name a ray, first name its end point, then name any other point on the ray. So I am using the word here initial point. What is the initial point? Initial point means starting point. I'll just give you some more examples by drawing some lines. So for example, the starting point is here A and this is B. It goes on in one direction, right? Here another one more example I just give you. So this is B and here it is A, and this goes on in reverse direction, right? See, in the first figure, the starting point, the initial point is A, right? So in the second, this is AB ray, and here in the second figure, the initial point is here. This is B. This is BA ray, and here the symbol of the ray is. The symbol of the ray is like this. Okay, AB is. So AB is not same as BA because their directions and initial points are different. Okay, AB and BA in these two figures, they are not same. Why? Because so these two rays are not same because their initial points are different. Now how to measure the length of a line segment? Let's see. For example, here if I take a point A, if I draw a line here up to, I just extend it up to here, point B. Now I just want to measure this. Take a ruler. Okay. The 0 mark on the scale is at 1 point. Okay. And now we read the mark on the scale which is on the other end. See, it stopped at, so 0 to, you can mark 7. So it's 0 to 7. Okay. So we say that the length of this line segment AB is 7 centimeter. Centimeter are the units. Okay. Now here we have measured the length of a line segment. Now how to draw a line segment for a given length? For example, the length is 5 centimeter. We have to draw a line segment. Just place this ruler on a paper and hold it like this, which I have shown here. Mark 2 points. Let it be A and B. Okay. A, say from 0 to initial point to here we have given 5 to here B. Just mark A and B. Now pressing the scale evenly, join these 2 points A and B with a pencil or a pen. So the line segment AB drawn is the required line centimeter of the length 5 centimeter. Here you have to remember one more thing is, if instead of joining the points against the mark from 0 to 5, here is that, no? You had joined them against the marks 1 to 6 or 2 to 7 or 5 to 10. You would have still drawn a line segment of 5 centimeter long. Right? Right? So how to draw a line segment, how to measure a line segment, how to measure the length of the line segment and how to draw a line segment of a given length we had discussed right now. Coming to the other concept, that is plane shapes. Till now we discussed a line segment, a ray, how to measure the length of the line segment, how to draw a line segment of a given length. Now we are going to discuss. Regarding this, I had uploaded a small video regarding the shapes and the sides and the name of the shape. I'll give the link in the description box. Please check out that. So coming to plane shapes. What is the plane shape? A shape that can be drawn on a plane surface. A shape that can be drawn on a plane surface means a sheet of a paper is called a plane shape. Some of the plane shapes, I can give examples. Those are rectangle, square, triangle and circle. Let's see rectangle. So rectangle. I'll draw a small figure here. I'll draw a small figure that represents rectangle, and these are the diagonals. Okay, so it has how many corners? So this is a corner. It has 1, 2, 3, 4. So I can 1, draw like this, 2, 3 and 4. Corners. Corners are also known as vertices. So vertices are nothing but corners. So a rectangle has 4 corners and 4 sides. So this is the side. 1 and 2, 3 and 4. It has 4 corners and 4 sides. If you measure its sides, you will find that opposite sides are equal. So these 2 sides are equal. Here these 2 sides are equal. Right? The line joining the opposite vertices. So this is the line which I have drawn. The line joining the opposite vertices of a plane shape is called a diagonal. This is diagonal. So rectangle has 2 diagonals, right? So what is a diagonal? Means the line joining the opposite vertices is a diagonal. As can be seen from the figure, a rectangle has 2 diagonals. So if you measure them, you will observe that the diagonals of rectangle are of equal length. They are of equal length. Coming to square. Here I'll draw a small figure. So it has also diagonal. So here it has also 4 sides as a rectangle has. It has also 4 corners. So I'll just write 4 vertices. So V means here vertices, and 4 sides. In square also you have 4 vertices or nothing but corners and 4 sides. So 1, 2, 3, 4 and corners 1, 2, 3, 4. So what is the difference between rectangle and square means here in square you have all sides are equal, but in rectangle opposite sides are equal. Okay, if you measure here its sides, you will find that all sides of a square are equal, and a square also has 2 diagonals. A diagonal means the line joining opposite sides of the vertices is nothing but a diagonal. And a square has also 2 diagonals. So this is the diagonal. These diagonals are of equal length. So this is a small difference. Here opposite sides are equal, but in square all sides are equal and the remaining is same. Here it has 4 vertices or corners, 4 sides. Here also it has 4 vertices or corners and 4 sides. Coming to triangle, I just show here. Triangle, I just draw a shape like this. Right. Here a triangle has 3 sides. First I'll say corners. It has 3 corners and 3 sides. Right. The sides may or may not be of the same length. Okay, this is one type of triangle. I can draw like this also. This is also one type of triangle. Right, I can draw like this also. This is also one type of triangle. So here the sides may or may not be of same size. But in rectangle you can see opposite sides are equal. But in square all sides are equal. Here in triangle the sides may or may not be of the same length. Right. Coming to circle. The other plane shape is circle. I'll draw a small circle. Okay. A circle has no sides, no vertices. It has 0, 0. Just think it doesn't has any sides and vertices. It has center, which we can represent it as O. O is the center of the circle. And the line joining the center to any point of the circle is called, you can write here, radius. Any point, from here to here also you can draw, from here to here also you can draw, from here to here also you can draw. The line joining the center to any point, of the circle is called radius. And here regarding this radius you will learn more in your upcoming sessions. So this is regarding plane shapes. These are also known as 2D shapes. Okay, our another concept is solids. These are 3D shapes. Let's discuss about solids clearly. So a shape that can be drawn on a plane surface is called a plane shape. Means plane surface means a sheet of a paper. But can you draw a football on a plane sheet? No, right? You cannot draw. Certainly not. Can you do the same for the tennis ball or a matchbox or a dice, a drum or an ice cream? No, right? So these are all solids. Bodies like these shapes, all called solids. So you can represent a football by a circle. Okay. So these are all 3D objects. They are not flat like the plane shapes. They are not flat like the plane figures. These are all 3-dimensional objects. But plane shapes are 2-dimensional, 2D objects. Okay, these are some of the solid shapes which are drawn. So the first one is a cube. The second one is a cylinder. The third one is a cone. Fourth one is sphere. And the fifth one is cuboid. So the best example can I give for cube is a dice. You have a dice, right? Like a cardboard box, a dice. For cylinder, a piece of a chalk. For cone, an ice cream cone, right? Or a hat. So if hat. For sphere, I can say globe. And for a cuboid, I can give you the best example is matchbox or a geometry box, right? And for cylinder, one more example I can give is the Coke tin or a powder box. So in this solids, we learn the new words are plane and curved surfaces. I mean, what is a plane surface and what is a curved surface? As you all know, solids occupy space, right? These are all occupy space. So the part of a solid which we usually see and touch is called a surface. Let's see. Let's see regarding plane and curved surfaces, which I had given the examples for you to understand clearly regarding this concept, plane and curved surfaces. So a solid occupies space, and what is a surface means as the part of the solid which we usually see and touch is called its surface. So here you look at the surfaces which I have drawn. So these two, I mean a book and this is blackboard. It is not black. I just drawn for assumption. And here it is a ball and here it is a balloon. So you can see the surfaces of the object shown below, and here it is, I can name it as plane surface, and these are curved. These are curved surface. So these two have different types of surfaces. The book and the blackboard have plane surfaces, but the ball and the balloon have curved surfaces. Some objects like unsharpened pencil, like cylinder shape. So I can draw here. So you can draw here. Okay, I am not taking any measurements. I am just drawing roughly to understand you clearly. So some objects like an unsharpened pencil or a cylinder, this is a cylinder, have both types of surfaces. They have both plane surfaces and curved surfaces. So this is, can represent like here, plane surface, and here it is curved surface. Right, so this is the concept clearly, that planes and curved surfaces. And the other concept in this is faces, edges and vertices. Vertices means corners. So let's see this clearly in solids how they will be shown. Okay, so we see faces, edges and vertices of a cuboid. So this is cuboid and this is cube. We'll see first for cuboid. So you can see this picture. This is a solid figure. I have already discussed the rectangular in plane shapes, rectangle, square, circle and triangle. So they have how many vertices and sides. Now we'll see what are the faces and edges and vertices in 3D shapes. So this is the best example which I have given: cube, cuboid, cone, cylinder, etc. So let's see here cuboid. So this is edge. So an edge is formed when two faces meet. So an edge is formed when two faces meet, and this is edge is formed when two faces meet, and this is a face. A face is a flat, this is a face which is a flat surface of this solid figure, and you all know this is a vertex. Can draw here. Vertex is a point where edges meet. Vertex is a point where edges meet. So a cuboid has 6 plane surfaces. 6 plane surfaces called faces. So these faces are all rectangles. So it has how many edges? It has 12 edges and 8 corners. Other word is vertices. So here similarly in cube also has 6 plane surfaces If you take a dice, you can know. So 1, 2, 3, 4, 5 and the back side is 6. So 1, this 2, 3, 4, 5, front side and back side is 6. So total 6 plane surfaces. So they are all squares. But in cuboid, those 6 plane surfaces are rectangles. In cube, those 6 plane surfaces called faces are squares. And it has 12 edges and 8 corners. Same. It is exactly as cuboid. You just got a doubt that what is the difference between cube and cuboid? Why? Because it has same plane surfaces, same edges, same corners. Between a cube and cuboid. What is the difference do we observe between a cuboid and a cube? I'll just show a small example. You just take a dice, right? Trace out all its faces on a sheet of a paper. For example, if I take a cube, so if I trace, I already told that it has 6 plane surfaces. They're all squares. 6 plane surfaces, they are all squares. Okay. For cuboid, the best example is matchbox. So trace out all its faces on a sheet of a paper. So it will be like this, at front side and back side, right? At the other side you will see like these shapes, and the other side you will just see like these shapes, right? So all the surfaces of a surfaces means faces. So all the surfaces of a cube are identical squares, whereas in case of a cuboid, all the surfaces are rectangles, right? Only opposite surfaces are identical. Surfaces are faces. Only opposite surfaces are identical. Coming to cylinder, the other 3D shape. So this is a cylinder and this is a cone. This is a sphere. So coming to cylinder, I'll just write here. So in cylinder, how many faces are there, edges are there, corners are there, we'll just see. So in cylinder, it has 2 plane surfaces, one at the top and one at the base. Okay, this is the top, this is base. So these 2 are plane faces. So it has 2 plane faces, one at the top and one at the base. So it has 2 curved, and it has only one curve. See, this is one curved surface. It has 2 curved edges. See, here at the top and here at the base. You can write here edge, here edge. Okay, so a cylinder has 2 plane faces, one at the top and the base, and one curved surface. It has 2 curved edges where the curved face meet its plane faces. See how it's meeting, right? And it has no vertex or corner. It has no corner or vertex. Coming to cone. So this is a cone. Here a cone has only one plane face, that is its base. It has only one plane face, it is base, and only one curved face. You can write here. So this is one curved face, right? So a cone has only one plane face, that is its base, and one curved face. It has one vertex. Here it's vertex or corner. It has one vertex or corner and one edge. You can write here edge, where the curved face meets the plane face. So coming to sphere. A sphere has only one curved face. It does not have any vertex or edges. It has only one curved face. I'll just try roughly. Okay, cylinder has 2 plane faces, short form like this. Okay, PF means plane faces. one at the top and one at the base, and one curved surface, okay. It has two curved edges, one and two, one at the top and one at the base, where the faces meet at the plane faces. It has no vertices. Vertices means corners, 0. So briefly you just understand this. Plane faces, curved surface, curved edges and vertices. This is about cylinder. How many vertices are there, how many curved surfaces, curved edges and plane faces. Coming to cone, you have one PF, plane faces, that is at the base, one curved surface, okay, and one edge, okay, where the curved surface meet the plane face, okay, and it has one vertex. So this is about cone. But in cylinder you have 0 vertices. In sphere you don't have any plane faces or edges or vertices. You have only one, that is curved face. You have only one curved face. So this is one curved face. I can write like CF. So PF means plane faces, CF means curved faces. The same here, CE means curved edges. Okay, edges. Here also same, one edge. But here you don't have any edges, you don't have any plane faces, you don't have any vertices. You have only one curved faces, curved surface. So this is totally about 3D and 2D shapes. So these are 3D shapes which I discussed regarding their faces, edges and vertices. So cuboid, cube and cylinder, sphere and cone. The last concept of this geometry is symmetry. Symmetry. So right till now we had completed dot, point, line segment, line, ray, plane shapes, 2D shapes, solids, 3D shapes, and the last concept is symmetry. So regarding symmetry, I'll discuss now. What is a symmetry? So if one part of a figure matches the other part exactly when it is folded, the figure is said to be symmetrical. For example, if I take this paper, if I fold this, so one part of the figure matches the other part exactly when it is folded. It is matched exactly, right? So this figure is said to be symmetrical. If I take another shape like this, so if I fold it, so the other part, it should match exactly when it is folded. So it is matched exactly when it is folded. So this figure is symmetrical. It is said to be symmetrical. Okay, I'll draw some figures here. So here the lines formed by the fold is called the line of the symmetry. Okay. Here the dotted lines in the following figures are the lines of symmetry. So the dotted lines which I have done here, these are the lines of symmetry. If I take this part, when I fold this, the other part is exactly matched when it is folded. Okay, this figure is symmetrical. So shape is said to be symmetrical if one half of it is placed in front of a mirror. For example, if I can say this one, it is symmetrical or not. This shape is symmetrical or not. It is said to be symmetrical if one half. So when it is placed in front of a mirror, you see the other half in the mirror. So each half is called a mirror image of the other. Mirror image. So it is called, each half is called mirror image of the other. Some figures and numbers like this, okay. When we fold this, it does not match exactly, okay. if I can give some more examples, like and one more example is like some letter I'll take here, right? So when you fold in this direction, first the letter, you just here the dotted lines in the figures or letter given here are not lines of symmetry. If the figure is cut along the dotted line, then the both parts when folded along the dotted line do not fit exactly onto each other, right? So symmetry means the figure, if a part of a figure matches the other part exactly when it is folded, is said to be, the figure is said to be symmetrical. So overall, this is the concept of symmetry. So finally, the geometric concept is completed. We learned point, what is a point, what are plane shapes, what are solids, what is symmetry, what is a ray, what is a line, what is a line segment, and what are 2D shapes, what are 3D shapes, how the spaces, edges and vertices differ from one figure to other figure, how to draw a line segment for a given length, how to measure a line segment. So overall, we completed the basics of geometry. If you have any other doubts regarding other chapters like algebra, statistics, whatever it may be, trigonometry, factorization, so there are many shorts which I have uploaded in my channel. Go to playlist, there you find many concepts. You just check out that. And if you have any doubt, please comment me in the comment section regarding that particular concept. I'll upload a new video. If you like this video, please do subscribe my channel, give your valuable feedback. Thank you. Thanks for watching.